Hi everyone, welcome to Mamsu Code video guide session. In the previous video, we looked at foundation service, how to have the setup made so that we can test the actual service by mocking all its dependency. In this video, we're going to write our first failing test and see how we're going to have the code that makes it pass. So just a recap on the diagram that we were looking at. So this is our console application. We ended up having a storage broker to save the sample record. And then now we started working on our foundation service, whichever is going to perform all the basic validation before saving the data. Once the validation has passed, it's going to call the storage broker to persist the data. So to test our business logic, we went ahead with our unit test project and we created our foundation service class, which is going to test this particular foundation service in the console app. Since our focus was just to test this foundation service, we went ahead and leveraged the mock library to say whatever is its dependency, just treat it as a fake reference. Okay, now let's go to coding. Just to recap on the code as well, we started with our interface, which is exposing a contract to add the sample record. And then we went with the service. We said it has a dependency with the storage broker. And then the method that's performing the actual addition is not implemented. Then we went with our test where we said for a test that's getting executed, we need to have the sample service prepared. So it's going to take a dependency of the storage broker, which is not the actual storage broker, but it's going to be a mock reference. Okay, now let's write our test. So here I'm going to have a partial class for the test itself. So sample service test. And right now I'm going to test my logic. So we say logic. And then what's the logic that we're testing? What is the operation that we're testing? It's add. So this, it's going to be red. If you override it, it's going to say the namespace already contain a definition. So what we have to do is partial class. In the actual class also, we should go declare it as partial. Okay. So here comes our test. To tell the compiler that this is a test, we have to attribute it with fact. To resolve it, control and dot. So this is the library which has the definition for what the fact is. Okay. And then now our actual test. So the test have to be in a public modifier so the compiler can execute it. So public, then what is the test going to be returning? As of now, it's going to be nothing. So we say void and then the actual method name, the test name itself. So the naming convention that we're going to follow is should add sample. So we're going to say what's the action that's going to perform. It should do something. What it should do, it should add something. What it's going to add, it's going to add the sample record. That's what we're going to name the test itself. Okay. Just for the clarity purpose here, we will use our comments to understand what the test is going to do. So given, so here I'm preparing my test data. Whatever is my data input that's going to come in for the service call, I'm going to prepare that. So that's the given section. And then comes the when section. So here what I'm saying is for the test data that I've prepared, when I am making my call, then what should happen? So that's the then section. So going back to the diagram, let's try to understand what's the given, when, and then from the diagram. So here what we're going to say is given my input record that's coming in, let's go with a diagram here. Message. Okay. Let's say this is our address. Okay. So as a user, they are preparing the address message. That's the input, the data that they're preparing. So they have filled in the address line 1, line 2, pin code, country, city, and everything that's required for an address. Now the message is coming into our console application. So we have a component that's receiving it. So let me just, call that component out here just for the clarity purpose, exposer. Okay, so this message is getting received by the exposer. So what does this exposer do? Nothing but receive and then propagate it to inside the application flow. So this address message is received from the client to the exposer, and then exposer propagates it to the next layer. In our case, our next layer is foundation service. Now, what does this foundation service do? It reads the address input and starts processing the data. Is it all valid or not? So in this case, we can say address line 1, is it valid? Does it have any value? Address line 2 is optional. Maybe a country code should be of 2 letters or 3 letters characters. And then the pin code, any validation that we want to perform, if it's going to have alphabets, if it's going to have special characters. So basically, we are just verifying all the data that is coming in before we go to our storage and persist. Is it all meeting our requirements? So that's the message that the foundation service is going to test for. And once all the test, all the code that is written for validation, everything looks good as per the logic, then this message actually is sent to the storage broker to save in the storage. So here, what we're saying is the given part. The given part is to mimic this particular piece, telling that I'm going to prepare an address data. I'm going to assume that is actually coming from the client or user or any other service that's outside there who's calling this foundation service. So I'm going to say, this is my given that I'm preparing my input when I call the foundation service. So that's the when piece. So given is anything that's before the foundation service that's happening, before the call happens. When part is actually when the call happens. Then what happens after we ensure the data is all good? Then what happens? It persists the data, it returns the data, whatever is persisted. So then is after you save the data, you're returning back the data. That's the then piece. So I'm going to validate if whatever I sent, have you saved it and have you returned it? So that's the given, when, then. Let's get to our coding and write the code for preparing our test case itself. Okay, just to understand, let's start with the when part. Now here, the when part is I'm going to actually make the call. So what I'm going to say is I have my sample service already prepared in this class, right? So this is the variable which holds the connection for the sample service. Why is it test classes must be public? So there's an error, right? Test classes must be public. So again, since it was internal, we have to make it public. Okay. Okay, so I'm going to say this dot sample service. And what is the method we are going to test here? That is add sample. And then if you see the contract, what it's going to add, whatever we're going to pass, right? So we need to prepare our input. So let's say what I'm going to pass, I'm going to call it as input sample. Okay, this is red because we have not defined it, right? Let's go define it. So I'm going to say sample input sample equals. Now I need to prepare something of data for the sample itself. So let's resolve this, control and dot. So it's going to use that reference. So you kind of, have multiple options. Let's see here. So now I'm going to say this is going to be my new sample. And what does my sample take? My sample is going to have my ID. And it can be 1. And my sample is going to have a text. And this is going to my test, whatever text that you want to pass in, right? This is how I'm preparing my input data. So there's a question that we can ask ourselves. Is it really a test data that we are preparing? So what we say in our development is like this is hard coded. For sure, anytime you run the test, the ID is always going to take the value 1. The text is always going to take the value test. So it's not a pure random generation, right? We cannot expect our users who's coming to the system will always be providing this value. So it has to be purely random. So in every single time when the test is getting executed, there should be randomly generated value that it gets tested for so that our services are robust enough to handle all different input data that's coming in. So we have an issue here. We cannot have something hard coded, right? Always 1 and always text. And there's something easily that we can try to do. So let's remove this piece. Now we are clear that we don't want a hard coded data. We want to create something random. So we can go with a method and then say that method gives you a random value. So here we can say create random sample. So what we want to achieve is every single time when this test gets executed, we purely want all random values. It can be 1, it can be 10,000, whatnot, given the limit of the data type. It can be any random value that we want to generate here. Let's go define this method. Since this method is kind of common for any number of tests that you're going to write in this particular sample service, you need a random data. So we can move this common method definition into this common class. So let's go here and then let's define this. Private static, since we don't want anyone to, initialize an instance for this and access it. So we're going to call it as static. Then what is this random method going to return? It's going to return the sample itself. So control and dot. Okay. And the method name that we have used is create random sample. Okay. So now what we have said so far is create random sample is the method. It's going to give you some random values of what? The sample being your object type. Okay. How are we going to generate? So let's learn something new. So there is this library similar to mock. There's an external library which is going to help us with a random generation. So that's called Dynamics Object Filler. Let's get into that. So here what I'm saying is it's going to generate a new value for every single time that it happens. So I can go and say, let me put it as a method first. What I'm going to say is filler of, it's not it's not detecting that. So let's first go install the library for it to detect. Manage NuGet, right click, manage NuGet package. Under the browse section, Dynamics. So there might be multiple packages out there for performing this operation. This is one of its kind. You can take a research and see how best which package works. Is it meeting all your needs? And this is the package that we want to install. So this library is going to help us with the random generation value every single time when we call it. Okay, so now what it's going to do is it's going to return a sample record, right? So let's hold that in a variable. So I'm going to call it as filler. That's a variable. And the method, the class that's itself is going to give you that option is filler of sample. The syntax for the instruction in the Dynamics object filler library, which says, for this particular model that I'm passing you, give me a filler instance of it. Then what we say is filler dot create. It's still not happy. So not all code paths return. You need to return it. Return. Okay. So just a recap on what we did was we wanted a random value for the data that we're going to test every single time. we don't want to always test for something 1 or ABC, 1, 2, 3, something like that. So we purely want our test to be robust, our service to be robust, to test every single possibility that can happen. So for that, we leveraged an external library, Dynamics Object Filler, and this is the syntax which instructs telling, give me a filler object of type sample. And when you say filler.create, so if you over this method, it tells you that it creates you the filled object. So now sample as an ID, it fills a value for ID, and sample as text, it fills a value for text. In case of address, if you say filler.create, it's going to populate you address 1 value, address 2 value, address line 1, line 2, pin code, country, and everything. So that's the library's beauty. It's going to give you a randomly generated value. So here, if you take a look at it, this particular method is doing 2 things. 1, it's creating your random object. 2, it's creating a filler for it. So we can, optimize it. What we can say is select it and say control and dot. You can select this, extract a method, and now you can give a method for it. So you can say create sample filler and enter. Yeah. So this method is going to give you the capability. So we are separating out every single method to just do one single thing. So here what we're saying is it's going to give you the filler object, right? So, and the object creation itself, we're going to move it out here. So what we can do is remove this. This is just going to return you the filler. And then what I'm going to do is dot create here. I'm going to create the object here. This return type will now change as it's the filler object. So just to have single responsibility, right? Let one single method handle one single responsibility. So the responsibility for this method is to just create a filler object. The responsibility for this method is to use that filler object, fill the data, and then pass it back. So here, if we see it's one line of code, so we can, since it's one line, it's automatically going to implicitly return it. So we don't need an explicit return keyword here. And here, if you see, we are creating a filler object and storing it in a variable and then returning that variable. Why do we need to store and then return? Why do we need a variable here? Because it's directly just returning, right? So again, we have an optimization here that's possible. So what am I saying is I don't need a variable since this is just one line. Whenever your method is getting called, I'm just going to return a filler object. That's all. So anytime when you write even a single line of code, just ensure if the method is just doing one simple thing so that our code is modularized and easy enough to scale up. Okay. So now this method is going to give you that value. Let's, quickly try to test it out. Let's have a breakpoint here. Right click and say run test. Since we have the breakpoint, we can hover the input sample and see what data is it coming up. Did I say run test or debug test? Okay, I think I did run test. So right click and say debug. So debug will actually, wait for the control if you have a breakpoint. So it's here. Let's over this sample, expand it. If you see the ID value here with something random totally, right? It's not what we thought of one ABC kind of a thing. Okay. Now let's stop it. Let's run it again and see if it's truly giving us random values. So again, debug test. And since we have a breakpoint here, let's over this, expand. And if you see, okay, wait. Yeah, so the value is truly random, right? So that we have our code testing for all possible scenarios. Nice. That's what we wanted. Okay. And the other piece, I think we are now learning how to write our code so elegant and self-explanatory, right? So there is a famous quote which says, coding, whatever you write, is not meant for machine to read, but for humans to read. So let's write our code such that it tells its own story. Here, what we are thinking is it's going to create a random sample. Why don't we name this as a random sample? That's what it's doing, okay? And then we tell them, okay, let me remove this breakpoint so it's visually visible. And then now I come and say random input sample is actually my random sample. So in this way, we are explicitly saying that I'm creating something random. I'm treating that random as my input. So that's your assignment here. I'm creating something random and I'm using that random as my input. Okay. So far, what we have done is our given part. Now we have prepared all our test data for the service to save. And here we're calling it as logic.add. The reason is we want to test the happy path scenario. So what does a happy path mean? Everything is green. Everything is so good. There's no error. There's nothing that's going to fail the transaction that's coming in. So if we have a request coming in for address, everything gets validated. There's no error at all. And then it goes to the storage and gets saved. So that's the happy path. In a non-happy path means something has gone wrong. It's not able to complete the transaction what it meant for. So that's the non-happy path scenario. Now what we're looking at is the happy path scenario. Always the data that we're preparing will be of valid data, so it can save it. So now we have prepared our data and we have said that this is what I'm going to say. Okay. Now what we want to do, after it's saved, it's going to give back something, right? If you over the add sample, the contract says it's going to return back sample. Means whatever you have passed, it's going to save that and it's going to return back that. Now we want to validate if that contract is good because it's meant to be doing that. It says you give me something, I'll save and I'll send you back that entity. What we want to validate is whatever you're sending me back, is it the same thing that I sent you? Say, for example, you are passing in an address, street number 123. And then the data is getting saved in the database or in any storage. And when it's coming back, what if it's coming back as street 456? Is that the data that you've sent? No. So you want to validate whether whatever you sent is what you're getting back. Okay. For us to do that, first we need to save the data that is coming back. Okay. What we want to do is prepare that data. So I say sample, actual sample. Okay. So whatever the service is going to return back, I'm going to save that. Okay. Now I'm going to save it, but what will I check it against? I'm preparing something, I'm passing something, I'm getting back. And I need to test, I need to validate if these two things, whatever is sent and whatever I'm receiving are same or not. Okay. Now what we can do is, this is another library that's going to help us come in handy for it. Let's go install that. So right click, manage NuGet package. This is going to be Fluent API library. So it says you're going to write code, which is going to be easier enough for you to test it out. Fluent assertion. There might be other libraries which is going to do the same thing for you also. So yeah, so this is the library. A very extensive set of extension methods that allow you to more naturally specify the expected outcome of a test-driven development. Okay, once you write the code, you'll actually understand what that fluency means. Okay, so what we're going to say is, whatever you're returning back, I need to ensure if that is same as what I sent. So we're going to say actual sample dot should be equivalent to input sample. So this is what the fluent, wording here is. It's simple, right? Whatever is actual that you're sending me back, it should be equivalent to whatever I'm sending in. So here, there's a better way of telling the story. So since we are telling whatever is the actual that you're sending me, I need to validate if that's my expected value. Instead of input, if it says actual is equal to expected, that's your story, that you're expecting something and you're expecting that is same as what you have received it. So let's go prepare our expected sample. I'm going to say sample expected sample equal input sample. So here I go and use that variable expected sample. Okay. So far, so good. What we have done so far is I'm going to test this sample method. Whatever I'm going to pass in as an input, are you saving it and coming back with that? And for that, every single time I'm going to test, I need to have a random value generated. So I went ahead and prepared a random method to give me the random value. And then I'm validating whatever you sent me back. Is it same as the expected one that I'm thinking of? Okay, let's go back to the diagram. There's one critical piece here. So we prepared our given, and then we came here and we said, whatever you're receiving, you're going to perform all the validations, and then you're going to save it and then give me back. So just a question, who saves it? Is it this foundation layer that is going to save the data? Or is it the storage broker who's going to save the data? Maybe you would have guessed it right. This is going to be the responsibility for the storage broker to persist the data, to save the data where you have coded for. In our case, we have used our in-memory storage. We have used list of sample entity to save it. So foundation layer's responsibility is to receive, validate, and propagate it to storage broker. Storage broker responsibility is to save the data. Okay, so we're missing something, right? So it says you're giving me something, I'm performing my task, and you're expecting me to give back this, but that has to come from somewhere who's saving the data. It's not the responsibility for this service to give back what is saved, because the save happens here. Now comes the beauty of our mock. So what we have done is we have taken a replica of the storage broker and we have mocked it. We have mimicked it. So now, since our responsibility of testing, our boundary of testing is at the foundation layer, we have to give instruction to the storage broker. Hey, storage broker, I've created a fake record of you. So if you are receiving a request from the foundation service to save the data, just do what I say and complete your activity. So let's go and do that. So here now comes the mock's power. What we're going to tell is this dot storage broker. That's our mock. That's our fake object that we have created, right? Dot setup. So you're setting up something. So you're going to instruct the mock to do something when it receives a call. So setup and the syntax is handle of the instance. And I say broker dot. Now, what is the method that is going to be called in this workflow? It's going to be adding the sample record. And the verb, the language that we are using at the broker layer is insert sample. Okay. So mock, whenever you receive a call for insert sample, and if you're receiving the call for this data, only then what you do is return me a data. So here the story is not fixing well. I mean, it's not stitched well. I'm going to pass you something in input. You return me the storage. You return me the entity that you have saved. So here, let's go prepare that sample. You can call persisted storage and whatnot, anything that you want to, relevantly use it for. So I go with persisted sample, and this is my input sample. So here I go and say my returning one should be whatever you have persisted for. You might be questioning, why are we doing all this random input, persisted, expected? Just write your code with just random, everywhere random, or just ABC. Is it going to read well? After 5 days, if you come back to this code, do you understand what it's going to do? It's better you write your code so good enough that it is self-explanatory. So that's what we are doing here. We're going to tell the storage broker mock to set up. What is going to set up? Whenever the broker is receiving a call to the insert sample with this parameter, with exactly this parameter, only then you return what is saved. Why do we want to say exactly this parameter, right? Remember our address sample? So we were saying that if I'm going to pass in my input of street 1, 2, 3, and you save that and you give me back. What if the user is passing 1, 2, 3, but the service is doing something else? And when it is telling the storage to save, it says, save me street 4, 5, 6. Then whose responsibility is it? So that's why we are mocking it in such a way that you save the record only when the record is matching what I'm sending. So that's why we are saying, do it only for whatever I'm sending you, save that and give me back this. So this is like mock. Okay. So now coming back to this storytelling, what is your expected? Are you expecting what you sent, or are you expecting what is saved? So you're going to validate something against what is saved, right? What is my expectation here? Whatever you have saved. So that's why we're going to say, what's my expectation here? Whatever you have saved is my expectation. That's what I'm going to validate against. If I'm sending you 1, 2, 3, and you're giving me something, if I validate it against with 1, 2, 3, it's not making sense. I want to validate with whatever you have saved. So that's why we're saying expected is coming from your persisted. Whatever is saved is what your expected is. Okay. Then we can do some more intelligent validation here. So what we're saying is my dependency in this particular workflow should be also validated. My expectation is that I will make you call to you, you perform the validation and call the dependency with whatever data I have given for. Don't make any other call. That's unnecessary. That's what we're going to validate. So what we're going to say is this dot storage broker. Now we're going to verify certain things. Broker dot. What's the method in our scope of testing? That's insert sample. I'm going to verify if you have received a call from input sample only once. So there's an error, control and dot. It needs the mock library. Enter. Yeah. So that's the story here. We are not just verifying the data that I'm passing in and passing that's coming out. I'm also verifying my dependency calls should be called or executed only for what it makes sense. That's why we are validating this, telling whatever the dependency that you have, I am verifying it. What am I verifying for? The method insert sample should have received a call with exactly the same data, and it should be received only once. It should be called only once. Okay. Another additional test that we can do is this dot storage broker mock. There's another thing called verify no other calls. What does this do? It ensures that not only this is getting exactly called, but no other calls should be made. So this is how we are making our test robust to ensure that the code is there only for the necessary or the requirement that it has to do for, not doing anything else extra. So that's the story here. Let's just read through, right? Given my random sample, which is my input sample, and from my input sample, that's going to be my persisted sample, that's going to be my saved one. And whatever you're saving, that's what my expected is as well. Okay. For you to perform the save, there's a dependency. Don't worry about it. I'm going to mock it. So I'm going to help you out telling this particular fake storage broker do something what I'm saying. So set it up with the method call insert sample. Whenever you receive the input of what I'm saying here, then only then you return me what's saved. That's my preparation. Now coming to the when part, the actual execution of it, I'm going to call the service. That's my focus of test. And I say execute this method for the data that I'm passing in. And my expectation is that once I call, you have to give me back the data that is saved. And now I'm going to verify if all that I want is there in place or not. The first thing that I wanted is whatever you're returning back should be same as what I'm expecting, what is saved. The second thing that I'm verifying here is the dependency call is only expected to receive one call for the method insert sample and for the exact value of input sample. The third thing that we're verifying here is no other methods inside this dependency call should be made. So this is our perfect test. There's one piece missing, but let's see that in action and then come back and fix it. Let's right click and run the test. Now I don't want to, have a breakpoint and see what the values are. So I just want to run it out. So I'm going to run the test. It's failed. So you can over this and read the message that says system not implemented exception. So this is our test driven development. So first we came and we understood the requirement. We're writing a test and then we're making it fail because we don't have the code for it. Now let's go fix this. So this will be the first commit that we're going to make in the foundation service. So as I said, this is going to be a series of videos, series of commits. And this is a perfect case for pair programming. So one person writes the fail test. The second person writes the pass test and then gives a failing test to the other person. So it's like a ping pong. That's an interesting aspect of development. Soon we will have our sessions recorded with all pair programming. For now, it's going to be me. Before making a commit, as usual, whatever activity that you do, run the code cleanup. So it's removed all the unnecessary references. It would have aligned any tab spaces or extra lines, all those things. And then we did run our test. We did run only one test, right? So it's recommended to run all other tests. So let's run the whole thing. Right now it's just one test and delete me is a temporary test. We'll delete the delete me test before making the pull request. So it's failing here as well. Just verify if the reason is right. Sometimes what if the test itself is wrong, right? It can fail for some other reasons as well. So it clearly says system not implemented exception. Perfect. So first commit, that's a failing commit. Go to your Git changes. So copy paste the test name and do a single arrow to say this is a failed test. And then make your commit. Perfect. Now let's go and fix it. So let's get into the sample service. What's the expectation here? It's going to receive data. It has to save the data. So who will save the data? This dot storage broker dot insert sample is the broker's equivalent method to save the data. And I'm going to tab, it's saving the data. What I'm going to pass, sample. So that's my expectation here. As soon as you remove that method, the system variable, system namespace is no more required. It went gray. Yeah, we'll come there. So let's go to our test again. Right click, run. Hopefully it passes. Yes, it's passed. So it's performed all the actions that is required here. Okay, so now the story is if you remove any one single line of code, things have to fail. So you write exactly what you want the test to do. Okay, so remember I said there's one thing that's missing. Let's take a look at it. Just for the sake of it, just to prove that is important, let's play around with our code. Here I'm going to play with my code. Since it's going to be a couple of lines that I'm going to write and just scoping it out. Return. Let me play with the code. What I want to do here is I'm receiving the data. I'm going to tamper the data. I'm going to overwrite the data. So for the sake of it, I'm going to say sample.text equals override. So whatever the user is passing in, I'm kind of overwriting it. I'm not going to save what the user sends. I'm just going to, miss it out. Now let's go run the test. What's our expectation? Now something is wrong because whatever the user is passed, that's what it's going to save. That's what we're going to expect. That's what we are going to validate. But here the code is tampering the data. Our test should capture it. Let's verify. Right click and run the test. Our expectation is it should fail because the data is not what we are passing. It's passed. That's not good, right? Why? Why did it do so? So bad. Technology is bad, right? Okay. So let's get back to the diagram and quickly look at a visual. Okay, here we are. Let me move this a bit. So far, what we have done is we created something called random sample, right? So behind the scenes, this random sample is stored in a memory. So in our storage, there's a memory, right? So it's in the memory. So what happens is this variable random sample talks to this memory. Then what we did, we said random sample, we're assigning it to input sample. Input sample. So I'm assigning it to this. So internally what happens? This input sample also refers to the same memory. So let's assume this is the data that it has in the memory. So address 123 Northeast California, and your country is USA. So if this is the data that's generated by this random in the memory, input is also referring here, which has the same data. Okay, then what did we do? We said whatever I'm passing is what my storage is going to be. So we went ahead and said persisted is a another variable that's getting from the input. So what it happens, it again refers to the same memory. Okay, there was fourth thing that we did. What we said was whatever is persisting, whatever is getting stored, that's what my expected is. So, and we went ahead and said, so this is my expected. Type over here, expected. So we said persisted is what I'm expecting. And expected is also the same memory. Okay, so let's come with this foundation service. Just moving it out here. So what did this foundation service actually do? It went and did something to the data. So it changed the data. So let's say it changed the data to 456. And immediately what happened? 456 memory, the data that's there residing in the memory, was referenced by all these people. And everyone treated that, okay, 456 is what my input is, 456 is what my storage data is, and 456 is what my expected data is, which is wrong. It's not that, right? Because 1, 2, 3 was the original data. So what we are going to do is, hey, engineers are smart. So I no more want to verify this memory. Let me go create another memory. And now here I have 1, 2, 3. Now I'm going to say expected is going to point to this memory and never to this shared memory. And now if my foundation service is tampering my data and changing 1, 2, 3 to 4, 5, 6, my test will still catch it because now I have separated out the memory. Okay, I'll provide a link in the description to actually understand how the memory allocation happens when you're assigning variables. There's something called value type, reference type. So that will help you understand the behind the scenes core technical aspect of it. Now let's go to the code and instruct to do this. So separate out the memory. Again, we do have one more friend. That's our library. Right click, manage NuGet package. So this time the name is deep clone. This library is going to help you to break the references. So deep cloner, small library for fast, deep or shallow cloning of .NET objects. Install it. And then let's go to the test it. So here what I'm saying is I want to break the link. But where do I want to break the link? I want to break the link for my expected. So that whatever happens behind the scenes for any other variables, my expected is standing alone for me to validate. So this is the syntax that takes care of this. Now let's run the test. So hope you remember we still have our tampered data here. Let's run the test. Run the test. Let's see if this takes care of any data. Okay, it's failed. Let's understand why it failed. Maybe this view is not convenient. This view might be convenient. Okay, so I'm doing this. So it says expected property actual sample.text to be Jove with a length of 3, but override has a length of 8 and it differs. Exactly, it captured that. I am passing in Jove as my input, but whatever you're returning me is not Jove, it is override, which is wrong. And this test captured it. So let's go clean our troubling code. And coming back to the single scope because it's going back to the single line. And we don't need this return. Okay. Let's rerun and see if it is intact. Okay, run the test. Passed. So don't forget, you're going to make a commit. So here I go and say this is pass. Okay, commit. So in the next video, let's take a look at the next set of test cases. So now our happy path testing is completed. In the next video, what we're going to look at is, what if my data is wrong? I need data in address line 1, but the user is not providing it, or my external person who's calling my service is not providing it. Now I need to fail. I need to say, hey, I am expecting address line 1, but I'm not receiving it. The data is invalid. So how do you ensure all your testing is covering that so that you have your code to address your business logic? See you all in the next video. Thank you for watching.